Okay, so my name is Philip Blackwell, and this is the video number 4 for Math 2000. It's the volume of a torus. Okay, so what a torus is, it's basically a circle rotated around the y-axis, and so it's centered at r0. So basically, these 2 points are this plus the radius and this minus the radius, and the radius of the circle is a small r. And what I found easier was to do it in terms of dy's instead of dx's, just because the way a circle is. And so I found the points, because this is centered at 0, or centered at y is 0, then the points of the circle intersect with y equals r, which is the radius of the circle, and then y equals negative r. And so what I did, I took the equation of this circle, which is x minus r plus y squared equals r squared, and I solved for x, so I could plug into the integral using dy. And so when you rotate this using dy's, let's say we're going to use the cross section at 0. When you rotate about the big R, the R plus R, you're going to get this huge thing that encompasses everything inside of this, all of that. And so what you want to do is, to get rid of that, you have to subtract by what you would get when you rotated about this smaller radius between the last point in the circle and the y-axis. And so what you would do is you would take the integral of r plus the square root of r squared minus y squared, and you would subtract that from your r minus the square root of r squared minus y squared, and you square both of those because they're both volumes, and then the dy. And so that would get rid of your inside piece, and that would basically create your torus. And so when you do that, after you do that, you have to simplify this, and you would multiply out the polynomial, and it would simplify to that. And so I took the integral of that from negative r to r, and I used trig substitution. And since this is in the form a squared minus x squared, because our r is the value, we just don't know it yet. And so I plugged it in my sign, and I got this. This was the dy. This is the r sign, and so 4 pi r from negative pi to r squared minus the inside piece. I simplified it, squared the inside, and then pulled out the r squared so I can get my trig identity, and this becomes r squared cosine squared. And so took the square root, and it became r cosine, but then we have this dy here that we had to multiply, and so you would get a r squared here, but I'm just moving it to the outside because at this point it's a constant, because r squared is a number. And so, and it'd be cosine squared theta. And so I went over here and I drew out my trig, my triangle, and because we're integrating from negative r to r, the point y is equal to r, and y is equal to negative r. So what I did, since y is equal to r sine theta, I plugged in the two r values, or the r and the negative r. And so when r is sine theta, r minus divided by r is equal to sine theta, and that becomes 1 is equal to sine theta. And at that point, sine is theta is pi over 2. And then the same thing with the negative r, and you get negative 1 is equal to sine theta. That'd be equal to negative pi over 2. And so I went back and I plugged those in, and then I got my integral set. Okay, and so then I just integrated this. And so I plugged in the trig identity, 1 plus cosine 2 theta over 2. I divided the 2 into the 4, and I'm left with this. And then I integrated, 1 becomes theta, and cosine 2 theta becomes 1/2 sine 2 theta. And then I evaluated it from negative pi over 2 to pi over 2. And so you plug in your you plug in negative or positive pi over 2, and sine at pi over 2, sine of 2, sine at sine at pi over 2 would be, this becomes pi and then it's 0. So that goes to 0, and the same thing here. This becomes 0, that becomes 0, and that's negative pi over 2, and since it's minus, the minus and the minus, they become a plus, and then you get pi over 2 plus pi over 2 equals pi, and so then you would multiply that in, and you get 2 pi squared r and the little r squared, and that's the volume of a torus.